natural numbers in DI. Now this idea is a simple idea but has a profound impact in terms of some of the DI questions that you face in the DILR section of the CAT. I'm going to give you a context of what I mean by that, and then I'm going to pick up two sets from the IIM Calcutta paper, which is the CAT 2018 paper, and show you this approach, how this approach in fact can save a lot of time. Right. So you see things like these in the DILR sets. Sometimes it says that something is a percentage of something else, or something is percentage more than something else. Here, for example, say A is 70% of B, or A is 75% more than B. Now, the natural thing for you to do is write something like this. If A is 70% of B, you take B as a base. So the base takes the value of X, and therefore A is 0.7 of X, right? Or if A is 25% more than B, you take the B to be equal to X. 25% more is 1.25 times X. Okay, this is something that you're very likely going to write. Okay, this is how you're going to represent this particular data. But there is another way to represent the same data, which is this. Right, which is kind of representing this using ratios. If A equals 70%, that would mean by 7 by 10 of B, or I can say that A by 7 would be equal to B by 10, or simply that A is to B is 7 is to 10. So if B equal to 10x, A would be equal to 7x, right? Or if I say A is 25% more than B, 25% would be 1 by 4 more. So if I take B and A, if B is 4, then A is 1 more than B, which is 5. 5 is to 4, or you like it 4x and 5x. And I would say these two are the same thing, but why is this different? Now, when you realize in a particular set that these values AB, let's take these values AB, are natural numbers. It could be number of coins, number of students, number of people. If they are a natural number, then this has a much more, I'm saying this is much better. You know why? If I look at the value 1.25x and A in fact is a natural number, tell me what are the values that A can take? It doesn't strike you immediately. But if I ask the same question here, if A equal to 5x and A is a natural number, what are the values that A can take? Even if you say that okay, A is going to take value 5, 10, 15, 20, 25 and so on and so forth. B, since it is a multiple of 4, 8, 6, 12, 16 and so on and so forth. In the same thing here, if I take what are the values that B can take? A is 75% of B and both are natural numbers. Tell me the values that B can take. It's not obvious, but the moment I write it like this has to be a natural number. The value that B can take has to be 10, 20, 30 and so on and so forth. And here the value of A can take would be a multiple of 7. Here is 7, 14, 21 and so on and so forth, right? So the point is that when you represent in this format, I write X here. This may not be a natural number. But if you write in this particular manner, this X has to be a natural number. So the point is, whenever I see natural number, I am not thinking decimal. I am thinking ratios. Simple idea, right? But you know the amazing impact this simple idea has? I'm going to take up two sets. Let's start with this 2018 sets. And by the way, the font size is 12. Now, you'll be able to read this without any problem in your laptop. But if you're using a mobile device, it might be a little bit of an issue. Only reason why I've kept this size as font is because I get some space to write things here. So one advice is that to use a laptop or a desktop to watch this video, or I have left this particular question set in the description box. You can check that one out and then solve it. Okay, anyways, okay. So let's start. This says there are 24 people. There are 24 people. People have to be a natural number. The first thing that I understand that I'm dealing with natural numbers. The moment I'm dealing with natural number, I don't see 75% as 0.75. I see 75% as 3 by 4. 4x, 3x. I don't see 60% as 0.6. I see 60% as 3 by 5. 5x, 3x. I don't see 20% as 0.2. I see 20% as 1 by 5. 5x, 1x or 5x, x. That's how I'm going to see these things, right? So that is something that you should see next time you realize that you are dealing with natural numbers. Now there are 24 people, a part of 3 committees which look at research, teaching and administration respectively. No 2 committees have any member in common. The moment that no 2 committees have any member in common, we are not dealing with set theory, we can deal with tables. Just create a table and then capture the information. So there are three committees. So we have committees R, T, and A, right? No two committees are of the same size. So okay, that is wonderful. R is not equal to T is not equal to A. Then it says each committee has three types of people. The number of committees has to be a natural number. The people have to be a natural number. You cannot have 1.5 committees, right? You have one committee. These are natural numbers. Each committee has three types of people: bureaucrats, educationalists, and politicians. So there are the types of people: bureaucrat, educationalist, and politician. I've kept this in small letter alphabet. This is bigger letter just to differentiate visually. Right, with at least one from each of the three type in each committee, with at least one from each of the three types in each committee, which means I cannot see zero anywhere in this table. I cannot see zero anywhere in this table. Zero as a value is not allowed. We are strictly dealing with natural number. We are not dealing with whole numbers. Right? We can't take the value zero. It has to be greater than zero. Right. The following facts are known about the committee. So the following facts are known. And then if I look at the question number 1 says which of the following statement must be false, which means three statements could be true, but one statement is definitely false. Well, number of bureaucrats, administration committee, number of educational in the research committee, at least two values will be able to find out. Which of the following cannot be determined uniquely. So which means that some of the things can be determined, some of them cannot be determined. But let's go ahead and solve this particular set. So we have to first create a table. Let's create a simple table, whichever. It doesn't matter what you put in row, what you put in column. But I'm just going to put RTA in each of these. And let's write PEP. And create a simple table. And we are now very used to creating the table. These creating such tables are not waste of time. It creates a absolute illusion of control. Control is very good. Control is very important. We need to have a total value as well. So let's put it like this: that B, E. I think that the size of this particular table is slightly small, but we'll manage with that. Okay. Maybe I should have drawn a bigger one, but we are going ahead with this. Okay. So this is a total value. That's a total value. What we know, the grand total is 24. This is 24, which means some of these three things has to lead to 24. Some of these things has to lead to 24. Few things that we know is R is not equal to T is not equal to A. These three values are different. What we also know is that I can't see any zero because it is mentioned that this one at least one from each of the three type of committee. That means that I cannot find zero anywhere else. So there is no zero anywhere else. Okay, let's start. The number of bureaucrats in the research and teaching committees are equal. Number of bureaucrats in research and teaching committees are equal. Okay. While the number of bureaucrats in the research committee is 75% of the number of bureaucrats in the administration committee. 70% of the number of bureaucrats in A. 75%. 3 by 4, 3x, 4x. That means that if administration is 4x, I'm going to write this on the right hand top because I want to write the numbers here. So I'm just going to write these variables there. So once I handle the variables, I'll write the value here. If this is 4x, that becomes 3x. That's what that means. Number of bureaucrats in the research committee is 75% of the number of bureaucrats in the administration committee. Now we also know the number of bureaucrats R is equal to number of bureaucrats in T. So this would be equal to 3x. That will be equal to 10x. This is enough for us to find the value. Why? I know that this particular value has to be a multiple of 10. What values can it take? It could take the value which is like 10, 20. Obviously, it cannot take the value 30 because the total here is only 24, right? Now, at this point in time, I'm thinking, can it take the value 20? If it takes the value 20, the total is 24. These two put together has to take a value which is equal to 4. Right, that is 20 plus 4 makes it 24. Now the problem is that you see these, there is 1, 2, 3, 4, 5, 6. There are 6 blocks. This should add up to 4. Now, but there are 6. The only way this 6 can add up to 4 is some of them take the value 0. But 0 is not allowed. So 4 is not possible. Because 4 is not possible, 20 is not possible. The only possible value is 10. We actually cracked the first row within no time by simply figuring out writing this particular manner. So this has to be 10. So this is x equal to 1. This is 10. That will be 4. That will be 3. And that will be 3. We don't need this anymore. Let's check this out. We got this value. Okay. Now, by the way, I think that this is enough to answer one question. Number of bureaucrats in administration committee, number of bureaucrats in administration committee is equal to 4. That's kind of like the 3 marks we got already, right? Okay. So, next one. Number of educationalists in the teaching committee, which is educationalists in the teaching committee, this value is less than the number of educationalists in the research committee. This value is less than this value, or RE is greater than RT. Okay, so this is less than that, or that is greater than this. So we just put it like this. Say, okay, this has to be greater. Whatever is value has to be greater than this. All right, great. Okay, the number of educationalists in the research committee, which is number of educationalists here, is the average of the number of educationalists other two committee. The other average of these two committee. This is average of these two. No, you know what? This is like you're almost thinking how many variables I should use. Actually, you can deal with this one variable. You know why? You must understand one thing. If this is going to be the average of these two, this will also be the average of the total. Yeah. Let me explain. Imagine this, teaching and A, okay, and there is R. We're looking at E. Okay, let's look at the total value for it. All right. Okay, simple. Let's look at teaching plus A put together. Let's take it's 4. Sum is 4. I don't know. It could be 1, 3, whatever. Sum is 4. Okay. What does that mean? Is that number of educationalists research committee is average of the number of other two committees. This is average of these two. Average of 4 between these two committee. The average of that will be equal to 2. Now, what is the total? Total is 6. You know, what will be the average value of this total given that there are 3 values? The average is going to be equal to 2. This becomes the average of the total. Let's take another value. For example, imagine this to be equal to 6. T plus A equal to 6. R is average of those two things. Average of 6 for 2 is 6 divided by 2 equal to 3. What is the total? Total equal to 9. What is the average of 9? Among these 3 things, average of 9, average of all the 3 would be equal to 9 divided by 3 is 3. This will be the average and this will be the total. The point that I'm saying is that if the number of educational research committee, this value is the average of the number of educationalists in the other two committee, then this becomes the average of the total. That means if the total is x, this becomes x by 3. The total is x, this becomes x by 3. But we don't want to deal with divided by 3 because we are dealing with natural numbers. I don't want to write like this. Instead of writing like this, if this is x, this will be equal to 3x. That will be the better way to write. 2, 3. If this is x, this becomes thrice of x. That's a better way to write this. So what I'm going to simply represent this is that if this particular value equal to x, we'll write it on top here, and this particular value will be equal to 3x. I'm using the variable x again because I've already deleted value, the term x. Okay. Now this can take the value 3, this can take the value 6, this can take the value 9, this cannot take the value 12. So there are 3 values that is possible, because if this takes the value 12, then this will become 22, this will become 2, but there are this is at least 3, right? Okay. But leave this here. 60% of politicians in administration committee, which is here, 60% of politicians are in administration committee. Total ka 60%, 3 by 5, 5x, 3x. And 20% are in teaching committee. 20% of the total are in teaching committee. 20%, 1 by 5, 5x, 3x. In both the cases, I can deal with the totalers. Now since I've taken 5x, let's take 5y here, which means 60% of the politicians are administration committee. This becomes 3y. 20% are in teaching committee. That becomes y. The total is 5y. This is y. This is 3y, which means this also has to be y. Okay, now can we just use natural numbers? What are the values that this can take? It has to be a multiple of 5. Now let's think. Okay, so this can take the value, let's say 5, 10, can't take the value 15 because the total only is 24, right? Now for the time being, check if this can take the value 10. We already have a 10. We need to get to 24. Therefore 3x should be equal to 4. How can 3x be equal to 4? Therefore, because this is a multiple of 3. 4 is not a multiple of 3. Not possible. Therefore 10 goes. So the value that it has to take is 5. And now 5 is very cute number. So this takes the value which is 5. This takes the value which is 3. This takes the value which is 1. This takes the value which is 1. So all this goes. Right? This is all gone. So this is 5. This is 15, which means this has to take a value which is 9 to make it 24. So that means this is 3x. That will be x. So that will be 3. Done. This total is 3 plus 3 is 6 plus 6 plus 1 6 plus 1 is 7. This total is 7. Now, I mean, we could answer some of the questions here. One more. What is the number of educationalists in the research committee? What is the question of educationalists in the research committee? Educationalists in the research committee is 3. Okay, that will get. That will get. Which of the following cannot be determined? I'm sure that we'll be able to find this. The number of educationalists in the 3 committee. Number of educationalists in the 3 committee. That's something that we can find for sure. Total number of bureaucrats in the 3 committee, that's something that we can find for total number of bureaucrats in the 3 committee is something that we can find for sure. And what else? The size of the teaching committee. The size of the teaching committee we don't know, depending upon the value that it can take. The size of the research committee is something that we know. Size of the value of the research committee we know that is equal to 7. So the size of the teaching committee is something, and so we could still continue to do this because we can finish this. See, look, this is 3. This has to be greater than this particular value, cannot be equal to 0. So only two possible values, 1 and 2. This has to take either value 1 or 2. Okay, there are two ways to deal with it. Either write 1 or 2 and fill it here only. We could fill the total here. We could probably do that. This can either take the value 1 or it can take the value 2. If it takes the value 1, the 3 plus 1 is 4. We need to get to 9. That will be 5. If it takes the value 2, 3 plus 2 is 5. We need to have 4. What is the total? 3, 4, 5. That's a total 5. Or this is 3, 4, 5, 6. 5 or 6. And then this is 4, 9, 10, 11, 12. Or 8 and 11. So that is two possibilities. You could probably write this as a separate table also. So R is not equal to T is not equal to A. 7, 5, 12, all those are different, and even 7, 6, 11 also are different. So what is the first question? Which of the following information must be false? Must be false. The administration committee. Okay, let's take first of all. Let's just snip this fellow here. Why am I fighting with this? Let's snip this person and get this here, and we can answer this without any problem. Okay, which of the following must be false? The administration committee, in the administration committee, the number of bureaucrats is equal to the number of educationalists. In the administration committee, number of bureaucrats is equal to number of educationalists is something that could be true, right? He's saying must be false. So this one could be true. So we eliminate this. The size of research committee is less than the size of teaching committee. Size of research committee is less than the size of teaching committee. Not possible. In both the cases, it is more than the size of the teaching committee. We have the answer. That'll be 2. We could check the rest for fun, but at this point in time, we can just take the marks and go on. But we'll still check. The size of the research committee is less than the size of administration committee. Size of research committee is less than administrative committee, which is absolutely true. And the last one, the size of in the teaching committee, the number of educationalists is equal to the number of politicians, which is actually possible. There you have it. So, what we did was to use what? The idea of natural numbers to make a life very, very easy. I'm going to pick one more set. This is another from CAT 2018. The IIM Calcutta set. This is a set theory set. One of the set that many people found it very, very painful to do. Okay, but we'll solve it. 1,600 satellites were sent up by a country for several purposes. 1,600 what? Satellites, natural numbers. 30%, not 0.3. 3 by 10. 10x, 3x. Right. The purposes are classified as B, C, S or O. 4 purposes. A satellite can serve multiple purposes, set theory. However, a satellite serving B, C or S does not serve O. So O is independent. So we get think about a set already that B, C and S are connected together. O is separate. Okay, so there is, it will look something like this. There is B, there is C, there is this one S. Okay, let's keep it slightly bigger. S. This circle looks very big, crazy circles, but that is okay. What is this? It doesn't look like proper circles. Sorry, I can't. S and O. Okay, ये है ना, basic ये है. Right, and then you actually look at the questions. So if you start reading the question, what can best be said about the number of satellites serving C? What is the minimum possible number of satellites serving B exclusively? If at least 100 of the 1,060 satellites serving O, what can be satellite S? If the number of satellites serving at least 2 of B, C and S 1,200 must be false. So we're not going to get the complete story. Some variables is going to remain, but we'll slowly start this systematically. Okay, that's all we got to do. The number of satellites serving B, C and S, though may not be exclusively, which means total B, total C, total S, are in the ratio 2:1:1. So B is to C is to S is to 1:1. What is that we can take out from here? We can take out something. There's a one thing that we can take out is C has to be equal to S because these two are same. Other thing that we can take out is that B is twice of C or twice of S because 2:1:1. B would be equal to twice of C or B equal to twice of S. Okay, that is the second equation. We also know the total number of satellites is equal to 1,600. That's all we know. I think where will we write this? The total is 1,600. Let's write it here. The total has to be 1,600. So total of this plus this plus this plus this plus this plus this plus 1,600. Okay. The number of satellites serving all three B, C and X is equal to 100. So we've got 100 here. Wonderful, fantastic, good. The number of satellites serving exclusively C is the same as the number of satellites serving exclusively S. Exclusive C and exclusive S is same. Okay, and this number is 30% of the number of satellites serving exclusive B. This number, these two numbers are 30% of this. 30% 0.3, 3 by 10, 10x, 3x. Which means if B is 10x, this will be 3x and this will be 3x. Wonderful. Alright, great. The number of satellites serving O is the same as the number of satellites serving both C and S but not B. Number of satellites serving O is both C and S but not B, which will be this. These two values are the same. That's it. So we need to invoke now one more variable. Let's call the variable Y. Let's call the variable Y. Okay, that's it. It's done. We have to now figure out the relation between these two fellows. What will you put? We'll have to put one more variable. Alright. Then we have to now take care of what these variables we have to take care of it. What are the things that we know? C equal to X, that's the one thing that we know. B is twice of C, that's the second thing that we know. Total is 1,600, that's the third thing that we know. Nothing else we know. So let's start. Okay, C equal to S. If C equal to S, now this C is equal to this S. Now this entire thing, S and this C are the same. If that is the case, these two are same. Y is for both, 100 is for both. If these are same, this has to be equal to that. It has to be. Now imagine, for example, you can think here, you can probably say, if you can't see this, you can say this to be equal to A, this to be equal to B, right? And then what is C? A plus 3x plus y plus 100. What is S? B plus 3x plus y plus 100. Now C is equal to X. That is equal to that. So 3x will cancel, y will get cancelled, 100 will get cancelled. Eventually A will be equal to B. So now we have to put one more variable. Let's put the variable to be equal to Z. Let's put here, we'll have to fill something out what Z means. Okay, we have got three variables. This is gone. We have only got two more equations, but your three variable, one variable is going to remain. Okay, let's hope that we'll be able to eliminate other two variables or write one variable in terms of other variable. B equal to twice of C. Let's do that. B equals to twice of C. Okay, we have to be careful here, but we'll be careful. What is B? 10x plus 2z plus 100. Wonderful. 10x plus 2z plus 100. That is B. 10x plus 2z plus 100. That will be equal to twice of C or twice of S. C is same, S is same. Okay. 3x plus Z plus Y plus 100. Okay. Twice of 3x plus Z plus Y plus 100. Okay. So what is 10x plus 2Z plus 100 equal to 6x plus 2Z plus 2Y plus 200. 2 into 100. Okay, 2z will cancel. Z is out. We can get a relation between x and y. We can write y in terms of x or x in terms of y. We don't want to write x in terms of y because we already have 3 times x, 10 times x. We want to write y in terms of x. That may be better. Okay, let's look at 10x. This will go 6. This will be 4x here. This will be 200. This will be 100. So minus 100. What remains is 2y, or we can write, okay, y will be equal to what? 2x minus 50. We got that. Y equal to 2x minus 50. This will be 2x minus 50. So we don't require y anymore. Y is gone. Thank you so much. 2x minus 50. This will be 2x minus 50. Great, 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 great. This is done. This is done. The second below is done. Now we have total is 1600. Add all this up. 10x plus z plus 100 plus 3x plus 2x minus 50 plus 3x plus 2x minus 50. That has to be equal to 1600. So total equal to 1600. How do we do this? Okay. Now let's start with how many x's are there? 10, 3, 3, 2, 2. 16, 17, 18, 19, 20. So we got 20x. Okay, how many z? 2z. Okay, plus 2z. What is independent number? Okay, 100, negative 50, negative 50, negative 50, negative 50, negative 100. 100 minus 100, 0. Ha, gone. This total will be equal to 1600. Or we can write what? 2z would be equal to 1600 minus 20x. What is z therefore? 800 minus 10x. Wonderful. Z is 800 minus 10x. So let's go on. 800 minus 10x. Z is 800 minus 10x. Okay, 800 minus 10x. So everything is done. This is also done. That's all. But what do we do from here? What do we do from here? This is something that is very, very simple idea. This can never be negative. And none of this value has to be negative. This cannot be negative. This cannot be negative. This cannot be negative. Those have to be greater than 0, which means 2x minus 50 should be greater than or equal to 0. This has to be a positive value. That means 2x has to be greater than or equal to 50, which means x has to be greater than or equal to 25. That means we have got a minimum value of x. Minimum value of x would be equal to 25. That's a bare minimum value. X cannot take a value less than 25. Alright, what else? 800 minus 10x. That should be greater than or equal to 0. That cannot be negative. 800 minus 10x. That has to be greater than 0. Or if I took 10x outside, 10x minus 800 should be less than or equal to 0. Same thing. So 10x should be less than equal to 800, or x has to be less than or equal to 80. The maximum value it can take. The maximum value of x would be equal to 80. This is what, or you can simply write x is between 25 and 80. That's a range. You can do that. Okay. Okay. That's it. Now we got this. We got this. We got this. Alright, we got all of this. Okay, we got all of this. Now. So at this point in time, we can go ahead, but we can also write something like, let's say, what would be B, what will be C, what will be S, what will be O, might be useful. O is 2x minus 50. That is something that we get. Okay, what is S? C and S are the same. C equal to S, C equal to S, C and S are the same. What is it? Let's look at how many x's are there. This is 3x, 5x, minus 10x, negative 5x. Alright, so we have got negative 5x, 800, the 100 minus 50, 800, 900 minus 50 is 850. This will be 850 minus 5x. This will also be 850 minus 5x. I think C is and X are same, but therefore it doesn't matter. Okay, and B is, you don't have to calculate this one because B is twice of C, so twice of this. 800, 850, 1600, 50, 100, 1700, twice of this. 1700 minus 10x. There you go. That is all we need to answer the question. Hopefully we'll be able to answer the question. Let's snip this information here. The total is 1600, and that's all we need. Hopefully we'll be able to answer this question. Okay, so we need to, let's reduce this size here a little bit. Okay, let's take this here, reduce this size. Oh, come on, reduce. Yeah, okay, and then put it this side, and hopefully use this to answer all the questions. Let's start. What can be said about the satellite serving C? So what is the total number of satellites serving C? We know this is 850 minus 5x. But we also know one more thing. What is the minimum value of x and the maximum value of x? What is the minimum x we know is 25. The maximum x, max x will be equal to 80. We can plug the value. Let's put the minimum value of x. We'll get them. So if we put x equal to 80, so x equal to 25. 25 into 5. 25 into 5 is 125. 450. 850 minus 125 will make it 725. So the one range we'll get is 725. They'll put x, and if we put 80 into 5, 8 5s are 40, 400. 850 minus 400. will be 450. We'll get the range 450 to 725. That's the range that we get for C. C will be in this range. Answer to this must be between 450 and 725. That's it. What is the minimum possible number of satellites serving B exclusively? Serving B exclusively is exclusively is 10 times X. What is the minimum number of value? The minimum number of value will be minimum value of X. What is the min value of X? Min value is 25. If X equal to 25, the min value of B exclusively would be 25 times X will be 250. There you go. Answer this question is this. Okay, now we got this one. If at least 100 of the 1600 satellites were serving O, what can be said about S? Now we have got new condition. At least 1600 satellites were serving O. Oh, what does that mean? 2x minus 50. Now 2x minus 50 now has to be at least 100. Initially, to get this value, minimum 25, we took 2x minus 50 as at least 0. But now we're saying at least 100. What does that give us? Okay, 2x will be at least 150. That means x has to be at least 75. So now, what is it? The minimum value of x now? Minimum x is 75. Maximum x is 80. Again, the maximum x is 80. Right? 80. So what is the new range? What is serving S? S is also thankfully the same as C, which is 850 minus 5x. Now we know that one of the range, if I plug in the value to be equal to 80, so which is the plug in the value to be equal to 80. 80 times 50 is 400. That would be 450. One of the range is 450, but the maximum, now we have to plug in the value which is 75. 75 times 5. 5 times 75. 75 times 5. 5 is 25. 375. 850 minus 375. 850 minus 375. We'll get it this will be 475. Okay, the maximum value will be 475. The range will be from 450 to 475. Therefore, at most 475 would be the answer to the question. Okay, great, wonderful. So let's look at the next one. If the number of satellites serving at least BCS is 1200, BCS is 1200, at least two, which will be these fellow, which these guys, this. Okay, no problem. This is simple maths. Don't worry. Okay, how many x's are there? This will be 800. So without 800, 1600. 100 minus 50 is 50. So 1650. 1650 minus 10x is minus 20x plus 2x would be 18 times x. 18 times x would be equal to 1200. Now you have to do some calculation and find the value of x. You know what you'll get is, I think that if you do the maths, x will become 25. I'm not doing the maths. Okay, which of the following must be false? If x equal to 25, we'll get every single value. The number of satellites serving C cannot be only uniquely determined. I can obviously determine. Actually, I don't even have to solve this question, because what you know here is you don't have to solve this. You can answer like this, because if number of satellites serving us at least 2 is 1200. If this is equal to 1200, is 1200, we'll get a unique value of x. We get a unique value of x, we'll get the value of b, we'll get the value of c, we'll get the value of s, we'll get the value of o. To say that it cannot be uniquely determined will be a wrong answer choice. We can check the rest, and we got this. Now this might be a slightly painful question, but the point that I'm saying in both these questions, one thing that, apart from, if you actually look at the maths that is used here, these are simple. These are not complicated maths here. These are simple maths, simple addition. I mean, you've had to find some range. Yes, those are simple addition. The only thing that helped us is that the 30% become 10x, 3x. It become very, very simple addition. Simple operation. In the previous question, what we found is the same thing, right? Instead of dealing this with in terms of decimals and stuff, if you understand it's a natural number, dealing in fraction, everything became absolutely easy to do. So next time when you identify something to be a natural number, think differently. It will save a lot of time, and I hope this made sense. Goodbye.